Hello, geometry, and welcome to the first video for lesson 4.5 covering systems of linear inequalities. This is the final lesson in topic 4 covering systems. So now in lesson 4.4 we did one inequality and we graphed it. Well, today we're going to do a system of inequalities, right? So that means you're going to have at least two inequalities to graph. Now again, remember with inequalities, the solution is not just a point, the solution is a space. So we're looking for a solution space. But this time, because we have two inequalities, we're going to look for the place where they overlap. So there's going to be two half planes that we're going to graph, and it's where they overlap that is the true solution to our system. All right, so example 1 says, what are the solutions to this system of linear inequalities? So again, notice here it says a system of linear inequalities is made up of two or more linear inequalities, and the solution is the ordered pairs that make all of the inequalities true, right? That's why you have to find the overlapping region from both solution spaces for each inequality. All right, so for the first one here, and I'll try to change colors to help you. So the first one, y is greater than x minus 2. So this is in slope-intercept form. Your b value is a -2, and your slope is not there. It's actually a 1. We're going to make it a 1 over 1. There's your slope. So we're going to graph this line. So -2 means go down 2 on the y-axis, and then a slope of up 1, right 1, slope of up 1, right 1, slope of up 1, right 1. We could also go down 1, left 1, down 1, left 1. There's going to be our line. So now we look at the inequality. It's a greater than. So greater than does not have an equal to. So we are looking for a dashed line. So I'm going to do a dashed line, not a solid. There we go. And because it's greater than, we're going to shade above this line. Now I'm not going to do that right now. I'm just going to put arrows pointing up. So I would be shading above this. So this top half would be the part that I'm going to shade, but I'm not going to because it gets messy. All right. So now I'll change colors and do the second line. So this inequality is y is less than or equal to -x plus 1. So again, we have our b value here of plus 1. Our slope is a -1. Make it a fraction, -1 over 1. There's your slope. So we're going to go up 1, and then we're going to graph down 1, right 1. Down 1, right 1, down 1, right 1, down 1, right 1. I'll go up 1, left 1, up 1, left 1. And there is going to be where my line goes through. Now, this does have an equal to, so it's going to be a solid line. So I'll make that solid line now. And again, just do your best, right? And then it is less than, so less than means we're going to shade below. So again, I will not shade, I'm just going to do arrows below. So now the question is, and I'll change colors, where would the overlapping, where would the two regions overlap? Well, if the red, you're going to shade above the red, and the blue, you're going to shade below, the space where they would intersect is going to be right here. The part above the red line, but below the blue line. And that's going to be your solution space. This is your answer. Okay, so again, we take above the red and below the blue. And that's it. All right, perfect. Let's do number 2. All right, so again, same thing. We're going to graph this system and find the solution space. So our first inequality is in slope-intercept form. Y is greater than or equal to -x plus 2. Again, there's your b. Your slope is -1. Put it over 1. That's your slope. So we're going to start with our b value, go up 2, and I'm going to go down 1, right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. I'll go up 1, left 1. Up 1, left 1. There. I do have an equal to, so that means I'm a solid line. So I'm going to make this a solid line. And I am greater than, so that means I'm going to shade above that line. So that would mean I'm going to shade up here and up here. So I'm above that line. Okay, the second inequality, y is less than -x minus 2. So now our b value is a -2. Our slope is still a -1. Put it over 1. Notice that your two slopes are the same, -1 over 1, -1 over 1. That should mean something when you graph, or if you think about it, okay? So we'll graph the b-value of -2. Then we'll count our slope of down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1. Good. I do not have an equal to this time, so I'm a dashed line. So I'm going to dash this line. And I'm less than, so that means below. So I'm actually down here. So now here's the problem, right? If I graph this, there would be red up here, and there would be blue down here. But where does the overlap occur, right? There is no overlap. So because there is no overlap here, that means there's going to be no solution to this system. Now notice that these two lines are parallel, right? That's what the same slope means. Because the slopes are the same, these two lines are parallel. And typically with parallel lines, here, parallel. Right, parallel. And typically with parallel lines, either you have infinitely many solutions. Either you have a solution space which is in between them, right here, or you have a no solution because they go in opposite directions. In this case, the shadings go in opposite directions. If for some reason you could shade in between these, say that both of the blue and red arrows were going the other way, so we were below the red line and above the blue line, then you would have the middle space as the solution space. Okay, so we're going to stop there and do video number 2. All right, keep on watching.